Session 16, Bottleneck Management. The quickest way to increase throughput is usually through bottleneck management. A bottleneck process step is the process step with the lowest throughput when compared to the other process steps within the process. Bottleneck process steps determine the throughput of a process, so knowing how to locate and remove bottlenecks is key to increasing throughput. At any time, one bottleneck process step is restricting the throughput of the operation. Removing bottlenecks is usually the quickest and lowest cost way to increase throughput. The first step in bottleneck management is to locate bottleneck process steps. To locate bottleneck process steps, look for accumulations of in-process inventory. Inventory may pile up and wait in front of a bottleneck process step. Process steps downstream of a bottleneck process step may have to sit idle at times while waiting for the outputs of the bottleneck process step. Bottleneck process steps may require overtime hours of operation to keep up with the other processes. Bottlenecks can be present in any operating department, including the office. If the bottleneck is a document process, there will be a stack of paperwork before the bottleneck process step. For example, an office worker may be a bottleneck and may not always generate production work orders in a timely manner, making production wait and causing customer orders to be late. In the example below, the paint share process step is the bottleneck. Inventory is backed up, waiting in front of the bottleneck process step. The downstream dry chairs process step is sometimes idle waiting for chairs. The throughput of the paint chair process step is 10 chairs per hour and determines the throughput of the entire process. In class exercise 20, the operators will review the detailed process flowchart from exercise 3 and locate the process step that is the bottleneck. It will be the process step with the lowest throughput. Answering these questions will help determine which process step is the bottleneck. Does inventory accumulate just before a process step? Do any process steps regularly sit idle waiting to receive inventory from the previous process step? Or do any process steps need to work overtime to keep up with the other process steps? Now that we know how to locate a bottleneck process step, how can we increase the throughput of a bottleneck? Rearranging the process formula that we discussed in session 11 can help us to find ways to increase throughput. The new formula states that throughput equals in-process inventory divided by cycle time. This tells us that reducing the processing time of a bottleneck process step will increase throughput. Reducing process downtime will increase throughput. Reducing setup time will also increase throughput. We can use the same methods already discussed in sessions 13 and 14 to reduce cycle time, setup time, and downtime in order to increase throughput of a bottleneck process step. In class exercise 21, the operators will use the process formula to see how reducing cycle time can increase throughput. Reducing cycle time by 1/2 from 4 hours to 2 hours and keeping in-process inventory the same at 40 chairs will cause throughput to double. If you reduce cycle time by reducing queue time by 1/2, in-process inventory will also be reduced by 1/2 from 40 chairs to 20 chairs, and throughput will remain the same. In other words, reducing processing time, setup time, or downtime will cause throughput to increase. Reducing queue time alone will reduce inventory, but throughput will remain the same. We will discuss this further when we talk about how to reduce in-process inventory. In session 17, we will look at a tool for increasing throughput called a task sheet.